So what I'm going to show you here is how to measure out the acetone for the first trial. And we've already poured in a bit of acetone, and it's up to probably about the 8 ml mark. Once we get to about 8 mils or 9 mils, it's best to use a pipette here to fill it the rest of the way. Now when you're doing this, you want to make it so it comes up to the meniscus. That U shape that we get for the liquid has to be on the 10 mark. Alright, you can go ahead and I'm going to zoom in here. You can see the technique here. So just one other thing about techniques when using these pipettes, I'll show you in a second. Here we go. So how do you feel about that?
Pretty good.
Okay, so the meniscus now is on the 10 mark. So the bottom part of the U shape that we're getting here is going to be down there. So let me show you a little bit of technique here with the pipette. One of the big temptations that people have with pipettes is they will tend to put them up like this when they're not using them. The problem with this is that the liquid that's in the pipette will tend to run into the bulb. And if you can imagine everybody doing this and using all sorts of different liquids, what's going to happen is that there's going to be a lot of contamination when you put it up like this. So the best technique is to hold the pipette up like this at all times. As long as the bulb is good, the liquid should stay in the pipette and won't drip out. If you're concerned about it dripping out, simply put it back into a container and just let it sit there. You'll notice also that we've got these 3 beakers of liquids here. We've got acetone, we've got HCl, we've got iodine, and it's really important that we label the acetone and the HCl, and these beakers have been labeled. We can't tell the difference between them otherwise. So I'm doing one of the trials here, and we'll see how long it takes and how we time it out. So Taylor, would you please go ahead and add in the water and the HCl and the acetone. So that's water that's there, that's 20.0 mils. This is HCl, that's 10.0 mils of the solution. And that one there is 10.0 mils of the acetone solution. Taylor's going to go ahead and get a temperature on that. So we're going to wait for a couple of seconds while it stabilizes, and then Taylor will mark down that temperature in her lab book. Looks like it's stabilized. We can go ahead and take it out. Now what's going to happen, could you please put the stopwatch in the shot here? Samuel's got a stopwatch, and he's going to hit that timer as soon as Taylor pours the iodine into the solution. She's going to do so fairly quickly. Would you please go ahead and do that, Taylor? Alright. Thank you, Samuel. What I'm going to do now is I'm going to zoom in on the beaker here. The Erlenmeyer flask, sorry. And what you'll notice about the Erlenmeyer flask was that it was dry at the start. And it's really important that we use a dry flask. Okay, just zooming in here. There we go. So you can see the color change in real time. I'm not going to speed this up, I'm not going to stop it. I want you to see the whole thing go here. Of course the times are going to vary depending upon the concentration, well not the concentrations, the amounts of each thing that we have in the solution. Now within trials they should be pretty much the same, so trial 1 and trial 2 of the same experiment should produce similar times. I would recommend doing enough trials of a single experiment so that you get 2 within 10 seconds of each other. The other thing I think that's going to be important is make sure that you take your solutions from the same bottles for the entire time. So I'm going to sit here and wait for this to change colour. It starts out as a yellow because it's iodine, and iodine is a brownish colour, and then when it becomes diluted it sort of turns into a yellow. As the reaction occurs, the iodine disappears because it's the limiting reagent, everything else is in excess. And it turns from a yellow colour to a colourless colour. It's a fairly quick change in that you get to see the difference between the yellow and the colourless. It's still coloured at this point. The colour is lightening up a little bit right now. It's now a lighter yellow, and Samuel will turn the timer off as soon as that colour changes. So it's getting there, it's not quite there yet, and now it's now the colour has gone. So there you go, that's how the change goes. So what we're looking at here is a situation where we're trying to get these both to around about 14 or 15 degrees. It doesn't really matter exactly what you get them to as long as you know what you're getting them to. And what we're going to try and do is get both of these down to that same temperature before we add them together. And then we'll maintain them at that temperature throughout the reaction so that we can have a constant temperature during that time. So what we've got is the iodine solution, 10 mils here, and in this one we've got 20 mils of water, 10 mils of HCl and 10 mils of acetone. So what we're going to do now is we're going to put these into the buckets. Would you please do that? Now to each of them we are going to add water to the buckets. Now what's going to happen is, you go ahead.
Oh, hi.
Doesn't matter. About halfway. Now Jeff, what you're going to find is when you add it to that one, it's going to become buoyant. So you're going to have to hold on to that flask once you add sufficient water to it. There we go. Alright, I'm going to fix the shot here a little bit so we can get that into the camera. Okay, good. Right. Now what we're going to do, so you're going to have to hold that. Now what you're going to do is add ice to each of those so we can get the temperatures down. Now would you please use your hands, please, Julie. Use your hands, please, Julie. Thank you. Okay, that'll do. And on the other one, do the same, please. Now you'll notice the iodine is in a separate container. So it's a smaller container. It's going to cool quicker. Alright, I think that'll do it. Now give that a bit of a swirl around, Jeff. Julie, yours is fine. Now as we see this, I'm watching the temperature go down now. The temperature is going down on the iodine pretty quickly, and not so quick on the other one. This is why it's important that we try and get them to about the same temperature. But if the temperature gets too low, what we'll be able to do is just simply remove them from the solution there, from the ice water, and that will enable us to warm up the solution. The other thing we can do is we can put our hand around it, and that will allow it to warm up as well if it gets down too low in temperature. So I'm looking at this and I can see that the iodine now is at about 18.8 and the other solution is at about 20.7. So as you can see, the iodine is cooling a lot more quickly. So Julie, once it gets down to about 14, I'm going to ask you to remove it from the ice water. Just hold it above the ice water, okay? So it's about 15 now, that's fine. And the temperature keeps on going down. At around 14, go ahead and remove it. Okay, just leave it out of the water like that for a little bit.
Should I put it down?
It's up to you, you can put it down if you like. But just make sure that that's in the shot, there we go. So the temperature is continuing to drop, but that's alright. Because the other one is still going down here. So the other solution is at 17.1. This one is at about 12.3. So Julie, what I'm going to get you to do is just put your hand around it, like that. And just turn the thermometer a little bit so it's more in the shot. There we go. And you can see that by her putting her hand around it, it's stopped the temperature from going down and now it's beginning to go up. So what I'm going to try and do is, I'm not really going to try and necessarily get it to a specific temperature. I just want them the same temperature when they're added together. And that'll be your aim as well when you're doing this. So this is getting close to 15. I'm thinking what we'll do is, as that's coming down and this one's coming up, once they get to be the same temperature, that's when we'll add them together. Make sure you get your timer ready, because you're going to have to start the timer once the things get added together. So that's at 14.6 and yours is at 14.4 and 14.5. Okay, let's go ahead and add them together now. So that'll be the temperature you'll mark down, will be 14.5 degrees.
Now.
Now take it out, please, and give it a swirl. Put the thermometer back in. Yeah, it's best to keep the thermometer in there during that part, and you want to try and keep it around 14.5, which was where it was at when we added it. So what you'll do is, if it starts to, it wasn't now, it's 40, yeah, take it out, go ahead and take it out. Now the temperature's starting to drop, so put your hand underneath it. I mean, right around it. There we go, wrap it around it, there we go. So if you could please bring that down further so that the thermometer can be in the shot. There we go, that's good. Now you can see that the temperature's going up again. So go ahead and take it out and put it back in the ice bath. We're just trying to keep it at around 14.5. So now it's going down again. So take it out, put your hand around it, and just try and keep it at around 14.5. So this is the part where we're going to get the solution to around 40 degrees. And what we need to do is have these solutions separate. You can see they have separate thermometers in each of them. This is going to be 10 mils of HCl, 10 mils of acetone solution, and 20 mils of water. And there's the 10 mils of iodine in there. Would you please go ahead and put them both into their respective containers? Okay, good. And now you'll have to hold on to them while we add hot water to the baths here. The hot water here is at around about 44 degrees. So put it, yeah, just fill it up about, that'll be fine, about halfway for each, please. And what this should do is now be enough to raise the temperature of these solutions here. Now the water was around about 45 degrees, so I'm hoping that that'll be sufficient to get these up to around 40 degrees. If we can't get up to 40, that'll be fine. 38 or 39 will be fine. As long as both solutions have the same temperature, that's going to be the most important consideration here. Now if you don't have access to hot water, you can use a hot plate and heat the water to around 45 to 50 degrees and use that as your mode here. Now I'm going to ask you to add more water to each of these here. Okay, that'll do. And that'll do. Alright, good. Alright, now I'd like you to pour that hot water out, and we'll get some more hot water in a second. Not right now. Not right now. So okay, turn it off, Tiffany. So, thanks. So you can see we've got nice temperatures here. Presently we're at about 35.4 and 35.5, so they're nice and stable right now. Now what I'm going to ask Delaney to do and Sarah to do here is to empty those containers, and we'll put more 45 degree water in them so we can get them up to their optimal temperatures. Okay, yep, go ahead and add those in. We want these at the same temperature when we add them together. Okay, that'll do on the iodine. The iodine's going up a little faster now. So it looks like we're at, is it about 38 on the iodine now? Okay. I'd like you to pull the iodine out of the solution for a little bit. There we go. And keep an eye on the temperature. See if you can manage it so it stays at the same temperature as the other solution. I think what we'll do is we'll get this to 38 degrees and we'll do it there. What's it at now?
38. Just hit 38.
Yeah, just hit 38. So go ahead, Sarah, and add the iodine to Delaney's solution. But make sure you're timing it, right? You need to time it. Okay, you ready? Okay, so go ahead, add them together, give it a little bit of a swirl, Delaney. The temperature here is at about 38.4. I don't need to see the timer in the shot, that's okay. So go ahead and give it a swirl. Could you take it out of the container here? It looks like it's going to stay at about 38. It doesn't take very long. It's about 38, 39. So if you keep it within a 1 degree range, that's pretty good. As you can see, it's already beginning to change. So when it's hot, you'll see this reaction will go a lot faster. The cold one, however, will take a lot longer. So as you can see, that one's already changed. All right, thank you.